Hello! Welcome to the Summit Online talk on using machine learning to simplify identifying and managing fraudulent activities. My name is Eric Green, and I'm a solutions architect with Amazon Web Services based in Sydney, Australia. I specialize in machine learning and AI services, and I also have a background in applying advanced analytics and machine learning within financial services. During this talk, I'll give a brief introduction to some of the fraud issues we have seen at Amazon and Amazon Web Services, and also discuss the strategies we use internally to deal with these issues. I'll then talk about how machine learning greatly improves fraud detection abilities beyond rules-based systems. Then I'll go over how Amazon Fraud Detector enables you to quickly bring machine learning fraud detection capabilities into your applications. We will then spend some time to walk through the process of creating a fraud detector using Amazon Fraud Detector within the console. Now, after the demo, I'll go over some other resources that can help you build fraud detection capabilities in your applications. So let's talk about some of the fraud learnings we have from over 20 years of experience of dealing with it at Amazon and AWS. Now, Amazon and AWS have been dealing with many aspects of fraud during the 20 years of operating an online e-commerce business. In addition, we are familiar with many other types of fraud that come with being the first cloud provider. For example, know your customer and account takeover are problems we've had to solve since the earliest days of AWS. Our global footprint has also given us data to help us understand the fraud patterns from the 245 countries and territories that we now serve. So let's talk about some of the most common types of fraud we see. At AWS and Amazon.com, we see a lot of the same types of fraud patterns that you would see in banks as well as within online commerce. Now, fraud generally falls into three categories. Payments fraud is when fraudsters try to use payment instruments that are stolen or compromised in order to steal services. Now, this is the most common form of fraud we see in day-to-day operations. Now, also under this category is intentional non-payment. At AWS, like many other online services, you don't pay for your services until the end of each month. This creates a challenge as once you have given fraudster an account, they have a significant amount of time to utilize services and then skip out on paying for them. So understanding the risk when you first create an account is really important in order to manage these types of losses. Now, the second category is account takeover. This comes in various forms for us. Accounts acquired through the dark web, scanning public repositories, or social engineering can be taken over. To minimize this fraud, you need to quickly detect anomalous activity within an account to protect your customers. Now, the third category is abuse. A common problem we have at AWS is free tier and promotional abuse. This is when bad actors try to use a promotion and then apply it across hundreds of accounts to do something for free that would otherwise be charged for. Now, the best example of this is using multiple AWS free tier accounts to avoid charges. Another abuse example is when bad actors find a way to trigger a service or support phone call back to them so they can collect fees on premium phone number. Now, most of these scenarios are happening with small individual losses that only really add up to significant amounts when the attacks happen at large volumes. So every time your detection system adapts to one type of fraud, fraudsters will also adapt to get around your detection rules. So how you set up your strategy and framework in order to quickly adapt is really important to an effective fraud detection system. At AWS, we have spent over a decade building up fraud prevention systems from the ground up. Now, the framework we utilize consists of 4 different pillars that rest on a foundation of data. Now, the first pillar is prevention. Prevention is what you do in real time to stop bad actors from initiating fraud. This is hard to do and is especially hard to do without adversely impacting customer experience. The second pillar is detection. Since fraudsters quickly adapt to fraud prevention, rapid detection is an important aspect of any fraud system. Fraud detection works by looking for behavioral changes and anomalies in behavior. Now, automatically detecting these anomalies is difficult as they are hidden among a much larger set of legitimate events. The third pillar is containment. Containment minimizes the damage caused by fraudulent actors. If users are not fully trusted, they might get asked more security questions or have certain capabilities made unavailable during their session. The fourth pillar is remediation. Once anomalous behavior is detected, the data needs to be sent to a remediation system where humans can investigate and make decisions. Having that layer of rigor in order to manually evaluate fraud is important because you don't want to adversely impact legitimate customers. Now, all of these pillars need to work together. Detection data will feed into remediation systems, and remediation findings will improve your containment logic as well as your prevention and detection models. Now, by building these integrated systems and processes so they share data, AWS and Amazon have been able to bring fraud down to industry low levels while also minimizing customer friction. So let's talk about how machine learning fits into all the above. Now, at the heart of most fraud systems, you have a set of rules that have been built to capture the most obvious fraud situations. Now, examples of fraud rules include blocking IP addresses based on previous bad behavior, stopping transaction based on daily limit, or blocking activities that are outside of a customer's known geographic area. Now, rules are easy to implement and understand, and they can be manually improved over time when new types of fraud occur. Rules-based systems typically have real-time detection rates no greater than 50%, so they let over half of fraudulent transactions through. They also will often flag a high percentage of legitimate transactions as fraudulent, increasing manual investigation costs and impacting customer experience. Now, for AWS, machine learning plays a critical role in all four pillars of our fraud systems and processes. We've made large investments in machine learning over the course of the last 2 decades in order to help us improve our security systems. So let's talk about machine learning and how it applies to fraud. Now, machine learning can greatly improve a rules-based system. A machine learning model goes beyond simple rules, looking at patterns and relationships in data that a fraudster cannot easily get around without modifications. In addition, machine learning models are retrained on new data frequently and will adapt to changes in fraud patterns automatically. In general, we use 2 types of machine learning algorithms in fraud: supervised and unsupervised. Now, both types of machine learning algorithms utilize features to create a predictive model, and the features are the known quantities like location, email address, time, payment information, as well as many other types of data that can be collected. Now, supervised models are created using historical data that has a label. Now, a label is just the outcome that the model is trying to predict. For example, a model that is trained on credit card transaction data to predict fraud would have a label of fraud or not fraud. Now, these labels were manually created by investigators during the remediation process. The machine learning process consists of taking the features and labels from historical data and then passing them through the supervised algorithm that will train the machine learning model. Now, once you have the model, it can be used to predict fraud based on features from the new data. The other type of machine learning algorithm is unsupervised. Unsupervised machine learning algorithms need no label and requires no human labeler. Now, a good example would be an anomaly detector that identifies patterns in the data that stand out. For example, if the amount you spend every day is very static, and then you go on vacation and double your spending, that would be an anomaly. There is no label, just a change in the pattern of the data. There are many supervised and unsupervised algorithms that can be used in fraud, from complex neural networks to simpler linear regressions. Now, no algorithm is necessarily better than another. Some algorithms work better in different circumstances, and choosing the right one and training it with the correct parameters is important to having a model that performs well. Let's walk through a simple example of training a supervised machine learning model. Now, the first thing we need is a labeled dataset. In this example, we only have 2 features, X and Y. Now, this is just to make graphing the features easier, as a typical dataset would have tens or hundreds of features. The labels are represented by colors, orange being fraud, blue being legitimate. We now need to split our data into a training set used to train the model and a test set used to evaluate the final model. Using the training set of data, We create a machine learning model that takes X and Y as features and returns a fraud or not fraud prediction. The ML model is just a function with adjustable parameters that can be trained. Now the function boundaries are represented here by a red line that separates fraud from non-fraud data. So now that we have a model, we can evaluate its performance with the test data. The percentage of time the model correctly predicts fraud is called the true positive rate. The false positive rate is the percentage of time the model incorrectly predicts fraud for a legitimate sample. Now, once you have deployed a machine learning model, you still need to integrate it into your systems and processes. Now, the model itself will just give a prediction. You still need a rules-based system to determine outcomes. Now, for example, a model that is 70% sure a transaction is fraud could have a rule in place to trigger the application to request additional data from the customer. A model that is 99% confident might instead lock the customer's account and refer it to a case management system. Investigators would then research and label the transaction as true fraud or not, and this result is a ground truth label for whether the event was truly a fraud. New data, along with the new labels created from the manual remediation process, is then used to retrain the model at a later time, making the overall system adaptive to new types of fraud. In addition, the manually developed rules may also need to adjust over time as new types of fraud are discovered. Now, tens of billions of dollars are lost to online fraud yearly. Attacks are constantly changing, human review is expensive, and embedded detection logic spread across many different systems is hard to maintain. Now, when you add in the difficulty of building, operating, and maintaining machine learning system, it's even harder. Machine learning experts are expensive and hard to find. Complex machine learning models are often needed, data engineering is time-consuming, and models need to find comparatively rare fraud events hidden among a large set of normal activities. So we built Amazon Fraud Detector to help solve these challenges so you can detect more online fraud faster with machine learning and leave the heavy lifting of building, operating, and maintaining the machine learning system to AWS. Amazon Fraud Detector makes it easy for businesses to use machine learning to detect online fraud in real time, at scale, without the need for machine learning expertise and without writing any code. So Amazon Fraud Detector has pre-built fraud detection templates designed by Amazon's fraud experts to handle the most common types of fraud seen at Amazon. The service's automated machine learning pipelines create fraud detectors using advanced machine learning techniques without the need for data science expertise or coding. Now, for example, during account creation, when there may be a limited amount of data, the service will automatically use special machine learning techniques that work best with small amounts of data. The available templates were developed from 20 years of preventing fraud on AWS and Amazon.com and uses pre-trained models developed using our own fraud detection systems. Now, for example, in the AWS account sign-up flow, we dynamically adjust the account verification steps required by new users depending on whether they are low or high risk. Using the account sign-up fraud detection template allows you to take advantage of these sophisticated models created with AWS data. Now, customers who already built fraud detection models with Amazon SageMaker can also import them into Amazon Fraud Detector and use them together with the standard Amazon Fraud Detector models. Now, finally, in the Service Console, you can easily review past events and the detection logic applied to them to help you understand how the prediction outcome was arrived at. So let's walk through how we create a fraud detector model. Now, the first step is to upload your historical fraud data sets to one of your Amazon S3 buckets. Now, as with all AWS services, you own and control your data, so this data is only used within your account to create a fraud model, augmented by other pre-built models from AWS. Now, data is critical for performant machine learning models. At AWS, we have a large amounts of fraud-related data spanning many years. The Amazon Fraud Detector service augments the uploaded data with other data such as location information, the network type of request, or the issuing bank for our transactions, as well as many other data features. Now, in addition to augmenting, we also engineer features. So examples of these calculated features include the geographic distance between transactions and also whether patterns found in the data match previously observed fraud patterns. We find that the amount of data combined with the calculated features and the augmented data greatly improves the fraud model's predictive accuracy. Now, once the data is uploaded, you now select a pre-built fraud detection model template. The currently supported template is for online fraud insights. Account takeover and transaction fraud are also coming soon. The service then uses your historical data as input to build a custom model. It will select the best machine learning algorithm for your type of data and then train and tune the model to work best with your data. The service will then evaluate your model and display the metrics as well as the false positive and true positive rates using the test set. Now, after you review the model, you can then deploy it through the console or with an API call. Models are hosted to provide a low latency, real-time endpoint that will automatically scale based on your request load. Now, after the model is trained, you need to evaluate and host it, and you also will create rules that will determine what outcome status the service should return based on the detector predictions. For example, a fraud detector that returns an 80% likelihood of fraud can return an outcome of additional security, whereas a 98% likelihood will return an outcome of disable account. Now, these rules determine how your fraud processes will work. Now, finally, you need to integrate the deployed detector into your systems and processes. This is done by calling the API from your application to receive real-time fraud predictions. Your application can then take action based on your configured detection rules. Let's take a look at an example API call. Now, in this example, an e-commerce application receives an order from a customer. The purchase information will have the originating IP address, the email of the user, and the bank the payment was made from. Now, there could be many other features as well. The application then calls the fraud detection endpoint, sending the details about the order. Now, the Amazon Fraud Detector endpoint will return the fraud prediction outcome as well as all the generated model scores. Now, based on this prediction, the application logic then decides what action to take on the order. If the model scores are above a defined amount, the application may reject the order or flag it for later review by an investigator. So let's go to the console to walk through creating a fraud detector from scratch. Everything I'm about to show you can also be done by calling the Amazon Fraud Detector through the API or through the AWS command line interface. So the first step in any machine learning project is to have data. So we're going to use a sample set of data that is available from the Amazon Fraud Detector documentation. Now, I've already downloaded the data to my local laptop, and now we're going to upload it to S3. But if you want to download this yourself, you can go to the AWS documentation page for Amazon Fraud Detector. Within the user guide, the first section within getting started, on the first page, there is a download for training_data.zip. So I've downloaded that and unzipped it. Now let's go to the AWS console for S3, and we're going to upload that data to a bucket that I've already defined called AWS Summit Online Fraud Detector. Now this bucket needs to be in the same region that I'm going to be running Fraud Detector, so you can see there that it's in the North Virginia region. So let's add those files and upload them. There are two files available. One is a simple file that has just the required fields, and there's a more complex file with more fields, and it's actually much larger. It takes longer to upload. So let's click through all the permissions and then start the upload. See, the required only uploads pretty quickly. And then when we get to the optional, it's going to take a little bit more time. Okay, so let's look at what this data looks like by querying the uploaded CSV file from this S3 console. So we'll do a select from, it's a CSV file format, and then we'll do show file preview. Now, as you can see, the file has just the required fields. It's IP address, it has email address, it has file timestamp, and it has the fraud label as the last column. Now the fraud label is 0 for legitimate events and then 1 for fraud. Okay, now that we have our data in S3, we can go to the Amazon Fraud Detector console page. Now the first step is actually to build a model. So let's click on the Build a Model button. So we'll call this My Fraud Model and then put in a short description that's optional. Once we have the description done, we can select a template. Now, right now, only template available is Online Fraud Insights. Coming soon is Account Takeover and Transaction Fraud. Once you select the template, it'll give you a list of the fields that are expected for that template. So you can see here we have email address, timestamp, IP address, and fraud label. You can also download a CSV file. It's a sample of what that CSV file should look like. The next step we need to do is actually create an IAM role that basically gives the fraud service permission to access the S3 data that we've uploaded. So we need to enter in the S3 bucket name. And we'll create a role that can access that bucket. I'll create. So now we have the IAM role. We need to enter in the S3 bucket location. So this is the bucket location plus the file name. So let's enter in we'll type in the bucket location and then I'll copy paste the file name. Okay, let's copy the file name. Okay, now that we have the file name entered in, we can hit Next. Now this takes us to the configuration screen. And basically on this screen, we need to map the fields, the input fields from the CSV file into what's expected by the fraud detector service. So let's start with IP address. So we click on IP address, and then we'll map that to IP address in the required model inputs. Do the same thing for email address. And we'll do event timestamp. We'll do fraud label. So now that we've defined the mappings for the fields, we also need to map the fraud label. As I said before, 1 is for a fraud and 0 is for legitimate events. So for the fraud values, we'll put in 0. We'll put in 1 for fraud events, and then we'll put 0 for legitimate values. Now we can click Next. So this takes us to the review and create screen. So here we can go and edit the name and description as well as the mappings if we need to. So we just do this, review this quickly, and then we can click on Create Model. Let's confirm, say yes, train model. So at this point, Amazon Fraud Detector Service is training a custom model. So behind the scenes, it's augmenting your data, applying feature transformations, and then also training the machine learning model, and then we'll be testing the model's performance. So depending on how much data you have, the training process can take anywhere from an hour to several hours. So as opposed to waiting, I'll pause the video and then come back when the training is complete. All right, so model training is complete. Now let's look at more of the details for the model by clicking on the version number. This takes us to a screen that displays the model's version and performance data. The version information for the model is at the top, but really the most important part of the page is the model performance. So as you can see, the AUC for the model is 0.96. The AUC measures how good the model is at separating fraud from legitimate events. So a perfect model has an AUC of 1. Generally speaking, models above 0.8 are considered good, and above 0.9 are excellent. Now there's also a short description on how to interpret the results with true positive and false positive rates, depending on the model score. Now we use this interactive graph to determine the rules and outcomes based on model score. So let's say in my business, every fraud case averages $10 to investigate, but every undetected fraud costs on average $100 in loss. So from a purely monetary analysis, we'd want to balance these costs by picking the fraud score threshold with the optimal true positive versus false positive rate. So by default, we see a fraud score threshold of 500 as a threshold being used to determine if an event is fraud. Now with this threshold, our detection rate will be 64.9%, with 0.9% of cases being mislabeled as fraud. Now the score distribution graph also allows you to move the threshold around to explore the trade-off between true and false positive. So if undetected fraud was much more costly, we could also lower the threshold to around 200. So let's try and do that. So you can see here at a threshold around 210, this gives us a detection rate of 82.2% and a 2.9% false positive rate. So picking this threshold is really driven by your analysis of your business needs. Now you could also have different outcomes for different thresholds. So for example, we could put in additional automated security checks for fraud scores above 34, but only mark fraud scores above 200 for manual research. Now on the right side of this page, there's also a confusion matrix that summarizes the true positive, false positive, and true negative and false negative rates for 100,000 events at the selected threshold. Additionally, there's an advanced section that displays the response operator curve for the model. This is mostly targeted at data scientists, so you don't need to look at that. Okay, so now that we have reviewed the model and determined the best score threshold to meet our needs, let's deploy the model. So model deployment will take some time, as internally the service needs to stand up some model endpoints. So I'm going to pause the video and come back when the deployment is finished. Okay, so model deployment is complete. Now up to this point, the model was just a data structure and storage. So by deploying it, Amazon Fraud Detector can now call it internally as an endpoint when evaluating fraud rules. So the first step is to actually add this model to Detector. So let's go to the Actions drop-down. Click on Add to New Detector. This will bring up the Define Detector Details page. We can enter in the detector name as well as an optional description. So after clicking Next, this brings us to the Add a Model page. Now, add a model, we can basically select the model that we previously trained, so My Fraud Model, version 1. You could have multiple versions for models as well that you could select, and you can also use a SageMaker endpoint and integrate that into a fraud detector. For this example, we're going to use the previously created fraud model, so let's click on the radio button for that, and then click Next. Now this brings us to the rule definition page. So in the rule definition, we basically would create a name for the rule and a description, and then an expression for when this rule is triggered. Now for this detector, we want to create a single rule that returns an outcome code of create fraud case when the fraud score is above 200. So to enter in the expression, we want to enter in a $sign, and this will give us a list of the available variables. Now we need the insight score for our model, so we select that. And then we enter in greater than 200. So once we define the expression, we also need to add in the outcome. As I said before, we want to use a create fraud case expression, so we'll use that as the outcome. And then we can click next. Now we can add that rule to the detector. Click next. You can also review the expression if you want to. Once we've added that rule to the detector, we can also define the order that those rules will execute in. Since we have a single rule, this isn't important. So now we can review and then create, and that'll create our detector. Now, once you've created the detector, you can actually test it out by entering in some test parameters. And then once you've tested things out, you actually want to call actions and to deploy the detector. Now, for this example, what I'm going to do is go to an SageMaker notebook. All right, so to test out the newly deployed fraud detector, I actually created a notebook in SageMaker, and I'm using the Botto3 API to get a fraud detector client. And I'm going to call that client 1,000 times using the same data that we used to actually create the model. So let's walk through that script to see what that looks like and get an idea of how you actually would call the fraud detector within your application. So first step, of course, we need to get the Botto3 API. And we also need to get the fraud detector client from the Botto3 API. Now, once we have that client, we also need to have the detector ID, the detector version, and also we need an input file to get some data samples from. So the detector ID is first fraud detector, detector version 1, and then we're going to use that, again, the same input file that we used to train the model, that synthetic 20K CSV file. Now we're going to have some counters to count on the number of true positive, false positive, legitimates, and fraud counts, overall counts, and also total call time. Now once we have, we will open the input file, and then we were going to call the CSV reader on that input file, and then read in all of the text, and then we're going to iterate over every row of that CSV, and then we're going to stop when we hit 1,000 rows. Now we'll keep track of the start time before we call the getPrediction API. And then when we call the getPrediction API, we need to pass in the detector ID, the detector version. We give it an event ID to identify the event, and then also the event attribute, which is the IP address, email address, and event timestamp. We'll get that response back, and then we'll keep track of the total call time. And then we'll start incrementing those counters. So we'll also look at the data. So if this is a true fraud, we'll count that as a fraud. And then we'll get the prediction from the response. And we'll mark that as predicted fraud or not. And then once we have the true fraud and then predicted fraud, we can calculate the counters for the true positive and false positives. Now at the end, we'll add up those true positive and false positives, and we'll have a true positive and false positive rate, as well as an average call time. Now, as you can see, the output from here, the average call time is 125 milliseconds, over 1,000 calls. And then the number of predictions, we have 1,000 predictions with a detection rate of 89% and a false detection rate of 2%, which is actually much better than the confusion matrix we looked at previously, what we thought from a production workload. Now, again, this is because we're using the exact same data set that we use to train the model as to test the model. So in production, we want to do that training and test split and then run the test data through here to get a better idea of the true and false positive rates. So that's a quick run through of how to actually call the fraud detector. So let's go now talk about some of the resources we have to go and build your own. So now that you've seen how to build your own fraud detector, I really encourage you to go build one yourself. We have customers today working with Amazon fraud detection. So one example customer is Vacasa. Vacasa is the largest full-service vacation rental management company in North America, with more than 23,000 vacation homes in 17 countries, serving over 2 million guests per year. They're using Amazon Fraud Detector to accurately detect fraudulent reservations using advanced machine learning techniques without having to build their own data science and fraud development teams. Now, this allows them to improve customer experience and trust and also reduce losses from fraud. Now, currently Amazon Fraud Detector is available for preview in US East 1. To sign up for the preview, go to aws.amazon.com/fraud-detector. The latest documentation also has more technical information on the service. Now finally, there is also in-depth sample notebooks available on GitHub to get you up and building quickly. If you're ready to continue learning more about machine learning, we've also expanded the machine learning curriculum we use to train thousands of Amazon developers. We've also made this available digitally for free. We offer live classes with accredited AWS instructors who teach using a mix of presentation, discussion, and hands-on labs. You can also explore different learning paths tailored to your role in machine learning. Go to aws.training/ml. So thank you for attending this session on machine learning and fraud. Be sure to provide feedback, and thanks for watching.
So I'm Vishal, and I am a co-founder of Labyrinth, and I head tech here. Labyrinth is a end-to-end machine learning company. We specialize in image and video, but we also work with text, sensor data, recommendations, and a few other aspects of it. Over the last 3 years, we've solved over 15 different machine learning problems for various companies around. And recently, we released one of our own products called Vereasy for India, which is an identity verification platform which allows companies to quickly onboard their users and also be able to vouch for their identity. Well, all the solutions we've built for our customers has always been on AWS. On top of that, even our own product Vereasy has always been built ground up on AWS. We use services, apart from the fundamental services like EC2, S3, and all the security services like VPC and IAM, we leverage Elastic Beanstalk a lot because we're a small team and DevOps is something we do not want to do day in and day out. Elastic Beanstalk helps automate that for us. Vereasy is primarily an identity verification service, and all of our customers have a lot of traffic coming through, and they before used to use a manual team to verify their identities. But now with Vereasy, they're able to automate it at the scale of millions. Now, Vereasy was built ground up on AWS. Of course, one core part of Vereasy is the vision and the machine learning algorithms that can read a document, see the faces of the person, cross-verify with government databases, compare all this information together. And we also do a lot of fraudulent checks, for all of which we have various machine learning models and algorithms developed, which all run on AWS. And all the web service also runs on AWS, which passes requests onto the core ML platform that we've built. In our last 10 months of operation, AWS has enabled Vereasy to handle about 12 million requests coming through. One of the leading mobile gaming platform passed their peak IPL traffic through us, and we were able to scale up and scale down based on need on the fly with just a team of 2 people monitoring the system lightly. That's how powerful AWS was for us. Vereasy's architecture is sort of modeled after the Earth. We have 2 main microservices running. We call one the crust and the other the core. Now, crust is the outermost layer which receives all the requests from our customers. It handles the responses, it handles billing, it handles authentication, all of that. And the core is an internal microservice which runs all the long-running machine learning and query results. Now, by getting this sort of a decoupled architecture, we're able to independently scale up and scale down crust and core. And since one is independently scaling up is very important, and each of them runs on a different application on Elastic Beanstalk, which allows us to independently manage scale, predictive scaling up and scaling down, and availability of the service. Vereasy is still a young product, and we expect exponential growth in the coming months. The maturity of AWS, we believe, will allow us to handle this growth gracefully.